Good morning, students. Electrostatics, some questions for Neet and JEE. See, first question: three charges, 2q, q, and minus q, are located at vertices of an equilateral triangle. At center, electric field and potential. What about them? That we have to find. See, if we draw equilateral triangle like this, suppose here it is 2q charge, here it is q, and here it is minus q charge, for example. Okay, and as it is equilateral triangle, you have to find its center, so that it is center. So we know that for equilateral triangle, center to corner distance is same. Yes, center to corner distance is same. Center to corner distance R is same for all corners. Okay. Now see, first of all we will see scalar quantity, that is potential. That is potential, because potential is scalar quantity and addition and subtraction of scalar quantities are easy. So yes, we have total how many charges? See, here we have total 3 charges, 2q, q, and here it is minus q. 2q, q, and here it is minus q. Okay, so see, these 3 charges are placed here as shown in figure. Then due to this charge, potential will be positive. Due to this charge, potential will be again positive, and due to this charge, potential will be yes negative. Potential will be negative. Okay, so yes, due to this charge, potential is k 2q upon r. Due to this charge, it is k q upon r, and due to this charge, it is minus kq upon r. So these are these two terms cancel out. So V is equal to 2 kq upon r, means V is not 0. V is not 0. Simple. Now what about electric field? Now what about electric field? So see, for electric field, what happens? Yes, at this point you have to find electric field. What is its direction? First of all, due to this 2q charge, it is radially away, means in this direction. Means in this direction. Okay. Now if I am assuming that due to q charge electric field is E, that due to q charge, electric field is E. Electric field is E. So see, as it is 2q charge, electric field due to it in this direction, it will be 2E. Simple. Okay. Now, due to this q charge, again electric field it is E. Yes, electric field will be E. It is in this direction. Here it is E. Here it is 2E. Now, due to this minus q charge, yes, due to this minus q charge, electric field will be towards. Electric field will be towards, and it will be in this direction, and it is also E. And it is also E. So see, you have these 3 electric field vectors in this direction, 2E in this direction, E in this direction, and E in this direction. Okay, there are no chances that the resultant will become 0. Because if you remember equilibrium of particles from chapter number 11, then 3 forces, due to 3 forces, one particle is in equilibrium when F1 is suppose acting in this direction, F2 is suppose acting in this direction, and F3 is acting in this direction. Then and then their equilibrium is possible. Here, these 3 vectors, they are in this direction, so their resultant is 0. It is not possible. Okay. So here, yes, electric field is again not 0. Electric field is again not 0. But if you are given, okay, it's 2q, q and minus q charges. Instead of that, you are given, okay, if you have 2q minus q and minus q charges, 2q minus q and minus q charges, then yes, due to this charge, potential will be k 2q upon r. Due to this, minus kq upon r. Due to this, minus kq upon r. So potential will become 0, and electric field, it will again become non-zero. Clear about this? So yes, it is one question which is based on electric field and electric potential. Now next question, see. The variation of electric field with distance as measured from P. See what is actually given. You are given one capacitor. It is positively charged, it is negatively charged. Okay. Yes. Two dielectric mediums having dielectric constant K1 and dielectric constant K2 are placed between two plates of capacitor like this. In this region, yes, it is F. In this region, yes, it is F. In this region, it is F. What is question? Your question is you have to find variation of electric field with distance as measured from P. In yes, chapter number 2 we have obtained one equation, and that is if it is capacitor having air, okay, and during this condition if electric field is E0, then when it is dielectric having constant K, then electric field in this region is E0 upon K. E is equal to E0 upon K. So yes, this point you have to remember. Okay, whenever air is replaced by dielectric constant, air is replaced by dielectric constant. Yes, electric field decreases. Electric field decreases, and see, E is proportional to 1 upon K. E is proportional to 1 upon K. Clear? And here you are given one relation between K1 and K2, which is K1 is less than K2. K1 is less than K2. K1 is less than K2. Clear about this? Clear about this? Okay. So see here the variation of electric field with distance as measured from P, you have to find that is, first of all, let it is electric field versus distance T. Versus distance T. Okay? Yes, as we have to find what about electric field. First of all, in this region it is air. So let electric field is E0. Sorry, electric field is E0. Electric field is E0 here in this region. Then it is dielectric. Dielectric having dielectric constant K1. So here you have to put E is equal to E0 upon K1. So yes, obviously electric field decreases. Yes, electric field decreases. Electric field decreases. Clear? So yes, it is value when it is E0 upon K1. It is E0 upon K1. Clear about this? Okay. Then, yes, again it is F. So again its electric field increases. Again its electric field increases. Okay. Then we have another dielectric medium having dielectric constant K2. But see, its dielectric constant is more. And what is the relation between E and K? Is inverse. Yes or no? So yes, electric field increases. So now I can draw like this. Okay? Like this. So yes, it is nothing but it is E0 upon K2. It is E0 upon K2. And again it is there. So yes, it will be like this. So it will be like this. Clear about this? So yes, it is graph of electric field versus distance when two dielectrics are placed as shown in figure. Clear about this? See, in this region F, in this region air, in this region it is air. In this region, as it is dielectric placed, its electric field decreases, E0 upon K1. In this case, as its dielectric constant is more, electric field will be less. Okay, so it is E0 upon K2. So yes, it is variation of electric field versus distance. One graphical question. Okay. Now, next question. You are given one figure. See, you are given one figure. Okay, next question. You are given one figure. See, 1, 2, 3, 4, 5. 5 plates are given. 5 plates are given. Okay, out of this 5 plates, 1, 3, and 5. These 3 plates are connected with positive terminal of cell, while second and fourth they are connected with negative terminal of cell. You have to find charge on plate 1 and 4. You have to find charge on 1 and 4. Plate number 1 and 4. First of all, how many capacitors will form, and what is resultant capacitance? Because to find charge, first of all we need how many capacitors are formed. So yes, first capacitor is between 1 and 2. Second capacitor is between 2 and 3. Third capacitor is between 3 and 4. Fourth capacitor is between 4 and 5. So yes, total 1, 2, 3 and 4. 4 capacitors will be found. Clear about this? Okay, so 4 capacitors are found. 4 capacitors are found. Okay, now these 4 capacitors, they are in which connection? They are in which connection? Let it is B negative and let it is A always positive. Okay, so yes, now I will find what is overall resultant capacitance. Let it is A and let it is B. First capacitance between plate 1 and 2. One is connected with A and second is connected with B. So it is first capacitor. Okay, then between 2 and 3. 2 is connected with B and 3 is connected with A. So yes, second capacitor. 3 and 4. 3 with A, 4 with B. Okay. Obviously, last one is also a parallel connection. So these 4 capacitors, they are in parallel connection. These 4 capacitors, they are in parallel connection. If separation between each 2 plates is A and cross-sectional area is A, so what is equivalent capacitance? Yes, C equivalent is 4C is equal to is 4 epsilon 0 A upon D. It is 4 epsilon 0 A upon D. Clear about this? So yes, it is equivalent capacitance. 4C is equal to is 4 epsilon 0 A upon D. 4 epsilon 0 A upon D. Now voltage V you are given. Voltage V you are given. Voltage V you are given. It is V. So what is net charge? What is net charge or total charge? You can say, okay, or you can say total charge. So total charge Q is equal to it is C equivalent into V. So is equal to it is 4 epsilon 0 A upon D into V. Clear? So yes, it is net charge, total charge. Now it is equivalent capacitance. It is total charge supplied. Now as these 4 capacitors are connected in parallel, and we know that in parallel connection charges are divided, charges are distributed. But see here, in parallel connection we know that potential is same. Yes, in parallel connection we know that potential V is same. And here each and every capacitor having their capacitance also same. Capacitance also same. So charge on each and every capacitor will also be same. The charge on each capacitor, charge on each capacitor, charge on each capacitor is equal to, see, what is total charge? 4 epsilon 0 A upon D into V. We have 4 capacitors and they are connected in parallel connection. So what is charge on each capacitor? Epsilon 0 A upon D into V. Clear about this? Okay, first of all you have to find equivalent capacitance. Then what is total charge? Then as these 4 capacitors are connected in parallel connection, V is same, capacitance is also same. So charge on each capacitor is this epsilon 0 A V divided by D. This total charge is divided in 4 branches. Simple. This total charge is divided in 4 branches. Now you have to find what is charge on plate, not capacitor. Not capacitor. So see, what is charge on first plate? Charge on first plate. What is charge on first plate? See, this first plate is here. And see, this first plate is only in one capacitor. Here, it is 1 and 2. Yes or no? A and B. Then second capacitor is between 2 and 3. 2 of B and 3 of A. Okay, this third capacitor is between 3 and 4. 3 with A and 4 with B. And fourth capacitor is between 4 and 5. 4 with B and yes, 5 with B. Clear? So see, first plate, it is only in one capacitor. First plate, it is only on one capacitor. So charge on first plate, Q is equal to it is plus epsilon 0 A upon D into V. Why? Because this first plate is connected with positive terminal. Why? What is charge on fourth plate? Charge on fourth plate. What is charge on fourth plate? See this fourth plate. This fourth plate is in 2 capacitors. See, this fourth plate is on 2 capacitors. Yes or no? Yes or no? 2 capacitors include fourth plate. So yes, what is total charge on fourth plate? 2 times, so its charge it is 2 epsilon 0 A upon T into V. But this fourth plate is connected with negative terminal, so its charge will be negative. So its charge will be negative. Clear about this? So yes, it is one easy question again. Okay, how to find charge on plate 1 and 4? Why here it is plus? Because first plate is connected with positive terminal. Why here it is minus? Because it is connected with negative terminal. Why it is only epsilon 0 A upon T into V? Because it is only in one capacitor. Why this fourth plate it is contained by 2 capacitors. That's why we have to multiply it by 2. Clear about this? So yes, these are 3 questions based on yes capacitors. Now next question. Now next 2 questions from combination of or grouping of capacitors. See first question. Yes, you are given the question. There are 6 capacitors connected as shown in figure. You have to find what is equivalent capacitance between A and B. Okay. See, yes, there is one method having common point. Means how to solve questions easily. See, it is point A. Let it is point B is there already. Let it is point. For example, it is P, Q, R, S, T. Yes, it is P, Q, R, S, T. Now, as we have to find equivalent capacitance between A and B. First of all, at ends, draw point A and B. Now, what is common point of A? Common point of A is Q. Why common point? What is common point? If between 2 points there are no electrical components, means resistor, capacitor or inductor or battery, they are called common points. Okay. So here, what is common point of A? It is Q. Similarly, what is common point of B? Common point of B is here it is S. What is common point of B? Here it is S. Simple. So yes, common point of B is S. Okay. Okay. Now remaining points, chalo A and Q completed. Then P and S completed. Now what about P? So see here it is P, but P no component R. So P and R common points. Again R T. So yes, this P R T they are called common points. P R T they are called common points. So I will indicate P R T here. That it is P, then here R, and here it is T. Clear about this? All points included. Again, P, no electrical component, R. So P and R common points. R, no electrical component, T. So P, R, T, they are common point. Now, how to solve this circuit? See, this first capacitor, C, it is between A and B. A is here, B is here. So yes, it is this first capacitor done. This second capacitor, it is between P and Q. P is here, Q is here. Second capacitor done. Okay, yes, it is done. Third capacitor between Q and R. Q is here, R is here. So yes, this third capacitor like this. So this third is also done. This one is between R and S. This here it is R and here it is S. So yes, here this one done. This next capacitor is between S and T. Here it is S and here it is T. So yes, it is like this. Okay, so this one is also done. Last one is between T and V. T is here and V is here. So yes, like this. Now it is easy to find which capacitors are in which connection. This C, C and C. This C, C and C. See, this 3C, this 3C and C, they are in parallel connection. So what is their equivalent? Their equivalent is 3C. What is their equivalent? Yes, their equivalent is also 3C. Their equivalent is also 3C. Clear about this? Now, then, see, it is easy. It is A. It is P, this 3C and 3C, they are in parallel connection, and we know that what is C equivalent? C equivalent is equal to, it is 3C divided by 2, it is 1.5 C. Simple. So yes, it is one method of common point. Okay, how to find such questions. Okay, now next question. See what is next question. Here it is. Again, you are given group of capacitors. As shown in figure. You have to find what is equivalent capacitance between P and Q. Equivalent capacitance between P and Q. So yes, again we will take some points. Okay, let's start. See, here it is P, Q. So now we will take names as that it is C, then let it is B, then let it is D. Okay, enough. Yes, enough. Now as we have to find equivalent capacitance between P and Q. Between P and Q. So P is common point, nothing. Q is common point, nothing. Then another points are, yes, another points are A. A is common point, no. B is common point, no. D is common point, no. See, this point, it is called D only, okay? It is also called D because it is common point. Okay? So yes, how to write down such points? Okay, let it is suppose A. Let it is suppose A, let it is suppose P, and let it is B, for example. Let it is B, for example. Okay? So now, this capacitor 2 microfarad. This capacitor 2 microfarad. It is between P and A. Here it is P, here it is A. It is 2 microfarad. Then this one. It is between P and B. It is between P and B. 2 microfarad. Actually, it is also 2. Now, this 5 microfarad is between A and B. This 5 microfarad is between A and B. This 2 microfarad is between A and B. This 2 microfarad is between A and B. This 2 microfarad is between B and B. It is between B and B. This 2 microfarad. Okay. This 1 microfarad is between B and Q. 1 microfarad between D and Q, and this 1 microfarad is also between D and Q. It is also between D and Q. So yes, it is your equivalent circuit. Now see here, students, it is this connection is nothing but Western bridge. It is Western bridge, and see this Western bridge. 2 divided by 2, 1. 2 divided by 2, 1. So yes, this Western bridge is in balance condition. How? 2 divided by 2 is equal to it is 1. This side it is 2 divided by 2 is equal to it is 1. So Western bridge is in balance condition. Western bridge is in balance condition. So yes, this capacitor you have to cancel. This capacitor you have to ignore. Why? Because potentials of A and B will be same. So yes, potential difference between them is 0. So capacitance will be 0. Simple. Okay, so yes, here this capacitor you have to cancel out. Then what is remaining circuit? So yes, if you ignore this capacitor, this 2 and 2 they are in series. This 2 and 2 they are in again series. So 2 and 2 like this. See, figure will be like this. Figure will be like this. It is P. Here it is Q. This 2 and 2 they are in series and their equivalent will be yes 1 microfarad. 2 and 2 in series, their resultant will be yes it is 1 microfarad. Here it is 1 microfarad. Here it is 1 microfarad. So 1 and 1 it will be 2. 1 and 1 it will be 2. That yes again 2 and 2 in series. 2 microfarad. 2 microfarad they are in series. So your resultant answer is 1 microfarad. Your resultant answer is this 1 microfarad. Clear? So yes, you have to redraw figure. Okay, what is given? Okay, which capacitors they are in which connection. Clear about this? So yes, it is all about for grouping of capacitors, and yes, this is it for today.